everybody, welcome back to another fun and exciting pre-algebra class. Today we are going to be in lesson 8.8, and that begins on page number 407, page 407. We're going to be talking today about experimental probability. What is experimental probability? Well, let's take a look down here at the screen and we'll try to figure out what it is. It says, well, we got to start with theoretical probability in order for us to understand experimental probability. So what is theoretical probability? It's where every outcome is equally likely to happen. This is what we've been doing, right? So heads or tails, it could be either one could happen. One doesn't have a preference over the other one. It's all random. Experimental probability. This is always based on what is being observed through an experiment or a survey. For example, if you're watching people go through the line at the cafeteria and you're counting or you're looking at how many of them like hot dogs and how many of them like chicken nuggets and how many of them like pizza, that is not theoretical anymore because it's not random. It's experimental because you're actually observing what's happening. This takes out the whole idea of randomness. If you remember in most of the questions that I've been asking you on quizzes and tests and things like that with statistics, you've been hearing me say randomly, this randomly happened. This was randomly selected. Those are all theoretical probabilities. Now, in this lesson, we're going to shift over and talk just a little bit about experimental. Basically, the idea of getting some information that will help us draw conclusions about what maybe the next person might pick. So if we watch somebody go through the line and 10 people get chicken nuggets and 5 people get hot dogs, maybe we're thinking that the next person will probably get chicken nuggets, right? Because 10 people got chicken nuggets and only 5 people got hot dogs. So you see what's happening is you're kind of making some judgment calls based on what you're observing through experiments, through surveys, through different things like that. Let's take a look at this. Basically the same example that I was just kind of using, but we'll actually use a cafeteria that has 3 different types of sandwiches. They have a ham sandwich, a peanut butter and jelly sandwich, and a tuna sandwich. Theoretical probability would say that each are as likely to be randomly selected. So 33% chance, right? 1 over 3 that they're going to pick tuna, 1 over 3 that they're going to pick peanut butter and jelly, 1 over 3 that they're going to pick ham. However, experimental probability would take into account which type of sandwich is preferred by the students because we took a survey, because we asked them, what kind do you like more? So the results are summarized in a frequency table. That's what we call these little tables that we write things in. So let's say that we observe something happening and we're going to do a frequency table based on these 3 different things. Let's say that there are 30 total students. So total, there are 30 students total in the school, and we take this survey. But let's say the ham people, let's say that only 6 people preferred ham. And this is the survey. Remember, we asked them, we got all the students together, and we said, what do you like? What kind of sandwich do you like? 6 of them said they like ham. The next one is the PB&J, and let's say that there were 15 of them that like PB&J. I happen to like PB&J, right? That's a good sandwich right there. So I'm probably in there with the 15, right? Where are you at? You in the ham? You in the peanut butter and jelly? Or are you in the tuna? I am so far away from the tuna, people, it's not even funny. I just don't like tuna. I mean, I can eat it. Like if it's the last thing on earth, maybe I would, be able to put down a tuna sandwich, but be a little bit challenging. I'm not a fan of tuna. All right. So 6 ham, 15 peanut butter and jelly. That's me. And then 9 tuna. Now remember, there were 30 total people surveyed. So these numbers right here should equal 30, right? So let's try it. 6 plus 15, 21, 21 plus 9, 30. Bingo, we got it, okay? So your total should always equal the different ones that you inputted. However many you input, that should always be your total. Okay. Now, how are we going to, what are we going to do with that information? Well, what we want to do with that information is we want to go ahead and figure out what the probability is that each one is going to choose. So let's say a new kid comes to the school and we want to know what's the probability that he's going to like ham, for example. All right, and this is called relative frequency. What you do is you take a ratio of the outcomes of the survey and you record that by putting the part over the whole. So we're just going to go back over here and we're going to go to ham and we're going to say, okay, what is the part? The part is ham. The part is 6. What is the whole? The total is 30. So ham is going to be 6 over 30. In this case, it is reducible, right? So 6 goes into 6 one time, and then 6 goes into 30 5 times. So 1/5. You could break that down into a decimal, 0.2 or 0.20. 20% would be another way to write that. So all three of those are different ways to write the ham. 20%, 0.2, or 1/5. And then we would go over here and we'll do the PB&J, and we do 15 over 30. We reduce that. That goes in 1, that goes in 2. So 1/2 is 0.5 or 50%. So half of the kids like peanut butter and jelly. And then the last one. Now there's a couple different ways to get the last one. One way that you could do it is, remember, your probabilities are always going to equal 100%. So you could take your 20 plus your 50 and you would get 70%, right? So this one has to be 30%. But let's go ahead and actually figure it out just to make sure. 9 over 30. We can reduce that. Let's see, 3 goes into both of those. So 3 and 10. So 3 over 10. So that's 0.3 or 30%. All right, so there's your different probabilities. They're all the same thing, right? So if we're doing percents, it's 20, 50, and 30. If we're doing decimals, 0.2, 0.5, and 0.3. If we're doing fractions, 1/5, 1/2, and 3/10 will be the way that that works. And then this one over here, we'll just do that for fun, is 30 over 30. That is your 100%. So 100% of the kids preferred some sort of sandwich of those three. All right, so that's what we've got. Now, we don't have a random. See, random would say, if we were doing random, this would be 33%, this would be 33%, and this would be 33%, right? Because they would all be 1 over 3, because there's only 3 sandwiches. So that would be the random. So this would be what we called up here theoretical probability. So these would be theoretical numbers because it's a theory that we haven't tried. These down here would actually be experimental numbers because we did an experiment. We sent a survey home. We figured it out. All right, so when we record all those results, we put them into a relative frequency table. That's what we did right there. This was our relative frequency table. So basically, this is our frequency table. And so this is our relative frequency table. And it's kind of ugly, so we could repackage that a little bit right here and just do it again. So we could put ham, PB&J. That's a J. There we go. Tuna and total. And we would just go through and we would just record all these. Well, what was ham? Ham was 0.2 or 20%. PB&J was 50%. And you could record however you want. Decimal, fraction, doesn't matter here. Tuna was going to be 30%. And the total was going to be 100%. And that's what's called a frequency table. So what is the frequency? The frequency is your percentage or your decimal or your fraction. All right, so shoppers were, and this example is on page 408 in your book. If you want to go ahead and follow along there, page 408. Shoppers were surveyed to determine their favorite flavor of potato chip. Out of those surveyed, 17 liked BBQ. you like BBQ? Yeah, I like barbecue. It's okay. I have another favorite. I like salt and vinegar chips, right? Have you ever tried those? Those are good. 14 liked plain. I don't know who these people are that like the plain ones. If you know them, message me or something, but I don't know who they are. So, and then 8 of them like cheese. I do like cheese. Usually like a little sour cream and cheese, something like that. And then 11 of them liked other flavors. So what we want to do is we want to go ahead and make, first of all, we're going to make 2 things. The first thing that we're going to do is we're going to make a frequency table, okay? The frequency table is just going to tell us how frequently that happened. All right, so we're going to go here, and we're just going to make our frequency table. And so we're going to have, like, BBQ, and then we'll have the plain guys, and then we're going to have the cheese, then we're going to have the other, and then we'll have we'll call this the total. Put lines in here, and this is ugly, right? And I'm sorry, I'm not an artist, I'm a math teacher, so you're going to have to deal with that. So now what I want to do is I want to put that 17 liked barbecue and 14 liked plain and 8 liked cheese and 11 liked other random flavors like me with my salt and vinegar. And now what we would do is we would add them up. So we do 17 plus 14, 7 plus 4 is 11, plus 8 is 19, plus 1 is 20, carry the 2, 2, 3, 4, 5, 50. We surveyed 50 people. So there is our frequency table. Now what we want to do is we want to find the relative frequency. We want to find our ratio for each one. So what we're going to do is now we're going to do 17 over 50. Then we're going to do 14 over 50. Then we're going to do 8 over 50. And then we're going to do 11 over 50. I'm just going to save a little bit of time right here, and I'm going to bust out my calculator, and I'm going to do these all on the calculator. So I'm going to do 17 divided by 50, and that is, well, 17 over 50. Come on, this calculator just gives me an attitude sometimes, right? All right, let me hit that button. 0.34. So this one's going to be 0.34. All right. And then the plain is going to be 14 over 50. So let's clear this out. Now we have 14 divided by 50, and that equals 0.28. So 0.28. And then we have 8 over 50. So you just got to keep doing this for every one. So 8 divided by 50 is going to equal 16.16. And then we have the 11 over 50. And that is going to give us 0.22. 0.22. Now, remember one thing that I said, this one's always going to be 50 over 50, right? And so one way to check this to make sure that you're right is to add all of these decimal numbers up. Or, you could add all these numerators up and hopefully get 50 out of 50 as well, which is what we already did right here. But let's do it with the percentages or with the decimals just to kind of make sure that it adds up. So we have a 4 and a 6, that's 10, and an 8 and a 2, that's 10. So we have 0, carry the 2. 2, 4, 6, 7, 8, 9, 10. There we go. We have our 100%. And so it all checks out. So go ahead and add those up and make sure. Now we need to put that into a relative frequency chart. Right now we have our frequency chart, and then we have our ratios, and now we need our chart. Let me do this. I'm going to kind of, just clear out some of this information right here. And I'm going to put our chart right above this. So I'm just basically going to add on to this. And we're just going to put these numbers up into that. We'll use percent. Since we found the decimal, we found the fraction. We'll make this 34%, moving the decimal 2 places, right? 28%, 16%, 22%. And the total then would be 100%. All right, so there we go. There is the top one is our frequency table, and then the bottom one would be our relative frequency table. All right, well, that's all I have for you in this lesson. Hopefully you learned something there. go ahead and try this. You might say, but Mr. T, there's more in this lesson. I'm going to do a second video, so that way it's not really, really long. This is already long enough. Okay, so I'm going to do a second video from this lesson, but you should be able to do those practice problems from this section. Go in there, try these, do your best. If you forget something, scroll it back and remind yourself and try it again. Okay, that's all I got for you. We'll see you later. Have a good one. Bye-bye.